like climate change, is caused by the massive amounts of CO2, carbon dioxide, that we've pushed into the atmosphere since the beginning of the Industrial Revolution. Over the last 200 or 300 years, much of this carbon dioxide has ended up in the sea. Now, when carbon dioxide and seawater meet, two things happen. The chemistry is quite straightforward. On the one hand, there's an increase in the number of hydrogen ions, and what that does is pushes the seawater down the pH scale towards acidity. It's about 0.1 of a unit. It doesn't sound much, but actually in real terms, it's about 30%, and that's very significant. The second thing that happens is that the amount of carbonate in seawater is reduced. Now, a lot of creatures need this carbonate to make shells and skeletons, and so they're obvious candidates, obvious victims.
It is expected that later this century, if CO2 emissions continue at the current rate, the average pH of the ocean will drop from 8.2 to 7.8. This relatively small decrease in pH may not seem significant, but it could impact many species of marine life.
Whether that be as providers of food for billions of people worldwide, whether as the main transport system on our planet carrying more than 90% of world trade, or as a reservoir of fuels like oil or renewable energies such as wind, wave and tidal power, they contain the vast majority of life on Earth, and through the plankton they affect our climate and give us every second breath we take.
The World Wildlife Fund estimates that over 80% of marine pollution comes from land-based activities. With numerous oil spills, chronic overfishing, and the growth of harmful algae blooms, scientists, citizens, and governments alike are scrambling to address the problems before they spiral further out of control.
Hypercapnia, which is an actual excess of CO2 in the body fluids of organisms, can happen in things like fish or squid and mess with their immune responses. Excess CO2 can even make it difficult for baby clownfish to distinguish among the odors of friends and foes and interfere with sensory mechanisms or even the ability to hear predators coming. Single-celled organisms called foraminifera and coccolithophores, which are close to the base of the food web and terribly important in marine ecosystems, are among the most effective. Coccolithophores produce a chemical that contributes to the formation of clouds. Some scientists even think that threatening the existence of coccolithophores could result in a reduction in cloud cover over the oceans, reducing the reflectivity of the Earth, and thereby increasing the rate of global warming.
Creatures like clams, oysters, and coral, their shells and skeletons are getting weaker. If you're among the 1 in 7 people who get most of their protein from seafood, or if you understand how unstable the world would be with 1 billion more hungry people.
Now, we have seen how ocean acidification is affecting the marine organisms on which human society and many natural systems are relying. Cold water has accelerated the dynamics of ocean acidification because more carbon dioxide dissolves in cold water. As scientists have observed, these impacts are high at places like Arctic, Alaska, and Pacific Northwest. The West Coast is in the front line regarding this issue.
In 2014, a Canadian shellfish farming company reported that they lost 10,000 scallops and $10,000 due to ocean acidification. But ocean acidification can be reduced by cutting the CO2 emission and taking the steps like investing in the alternate energy generation like wind power, converting the coal-fired plants to the natural gas power plants, which are generating half of the CO2. Encouraging the personal energy generations like turning off the lights or inflate the car tires to the proper pressure can also help in reducing the ocean acidification.